Well, hey everyone, and welcome back to another video in the series for the dungeon generation tutorial. In the last episode, we went and we got the rooms to be drawn now on the grid, which you can see here. If we zoom in, you can actually see the little rooms with our tiles. That looks like it's a real good room. And the way I'm moving like this in the scene view is when you press in with your mouse wheel, you can drag it. So that's all great. You can zoom out with the mouse wheel and move around. Got another room there. You'll notice how the rooms here are empty. That's because I made a bit of a mistake in the last episode. So, first of all, room is not supposed to be a mono behavior. So we're going to fix that right now. It's not a mono behavior. And then we'll just take mono behavior off. That. And then we'll save it. Now, I remember saying in the last episode, what we're going to work on this time is intersections. I personally do not want a room colliding with another room. I don't want that. So what we're going to do is we're going to go and we're going to write a function that actually checks to see when we're getting ready to place a room down, does it collide with another room that's already there in the list. So inside of the room class, we're going to go public bool intersect, and we're going to pass in a room called other. It's the other room this intersects with. Okay? And so by default, we're going to get it to just return false. It doesn't intersect with anything. So you can actually just place the room down, okay? Well, now we need to do some logic here. So when do we not want this to lay down a room? That's when this function returns true. If it intersects with something, we don't want it to return. So what we need to do is we need to check to see if this room overlaps the right top corner, if it overlaps the bottom left, the top left, or the bottom right. If any of the corners overlap the other room, we need to check if the width overlaps the other one, if the height overlaps the other one, or if this room is smaller than the other room, because there's a possibility that if the size of this room is smaller than the one passed in, you could place this room inside of another room. I personally don't want to do that. So that's what we're going to do on this entire function. It's going to seem a bit crazy, but this is how we're going to do. So this is what we're going to do. It's if, okay, if this dot right wall, okay, if the right side of this is greater than equal to the other room's x position. So remember, the x position and the y position, the x position represents the left wall. The y position will represent the ceiling. The right wall represents any position that is at the size of the wall to the right, the size of the room to the right, and the top wall represents the ceiling. So think of it that way. The top wall is the ceiling. The right wall is the right wall. The x position is the left wall. The y position is the bottom wall. So we're going to say, hey, is our right wall, okay, if the farthest to the right of this room is greater than or equal to the other's x position, which is its left wall, and this right wall is less than or equal to the other's right wall. Okay, so if this right side is greater than or equal to the other one's left side, and this right side is less than or equal to that right wall, that means its right side is in. That means the right side is inside of the other room. And we'll go to a new line. This dot top wall is greater than equal to the others dot y position, the bottom floor of the other wall, and this dot top wall is less than or equal to other dot top wall This right here is the entire line of code for just for seeing if the right top corner overlaps the other room. That is what this one does. And now we're gonna check for something else. We're gonna put all of these next three inside of pretty much one statement. So we'll do or. Okay, so if all of that comes true, if the right top corner overlaps the other right corner, we're gonna return true. So if all that happens, or we're going to check to see overlaps top left corner. This dot X position greater than or equal to the others dot X position, and this dot X position less than or equal to the others dot right wall, and this dot Y position. I'm going to explain this all, bear with me. This dot Y position is greater than or equal to other dot Y position, and this dot Y position less than or equal to other dot top wall or. Okay, so what does this say? So if the bottom, so if this dot X position is greater than or equal to the other's X position, and that number is less than or equal to their right wall, that means the bottom left corner of this box is somewhere within the left side and right side of the other room. It's within those boundaries. And if the Y position is greater than or equal to the other one's Y, and it's less than or equal to the other one's top wall, it fits within the size of this room from floor to ceiling. So if it fits within the side of the room from floor to ceiling and from left wall to right wall, that means the bottom corner of this room is inside the other room. It intersects. That's what this says. Then we'll come down here, and now what we're going to check is the top left corner. So, collapse, top left corner. Now the top left corner is going to be if this dot top wall is greater than or equal to other rooms dot Y position, and this dot top wall is less than or equal to the other dot top wall, and this dot X position is greater than or equal to the others dot X position, and this dot X position less than or equal to other dot right wall, or. So what this says is, hey, if my top wall, which the highest I can go, is greater than or equal to the other one's Y, which is their bottom position, and it's less than or equal to their top wall, that means my top wall falls somewhere in that room. And this dot X position, that means this dot X position is greater than or equal to the other's X, and its dot X position is less than or equal to the other one's right wall. So this dot x position, double check top left corner. So this dot x position is greater than or equal to the others dot x position, and this dot x position is less than or equal to their right wall. Yes, that means it falls within. And so then we'll come into here. And then we'll do overlaps. Bottom right position. Bottom right corner. Then we'll come into here and say this dot right wall greater than or equal to other dot x position, and this dot right wall is less than or equal to the other dot right wall, and dot y position greater than or equal to other dot y position. This dot y position and equal to other dot top wall. And then we'll close it off. Bam. All that happens, we return true. I know this seems ridiculous, but bear with me. I'm going to go over with you here. Okay. So, basically, if the right wall, if the right side of the room is greater than or equal to the other one's left side, and this right side is less than or equal to that right wall, and this top wall, and if the ceiling, top wall, ceiling, and if the ceiling is greater than or equal to the other one's floor, and it's less than or equal to the roof over there, that means this right corner fits inside of that room, and that's not what we want. So that means it would come here and say, oh, well, that means both of these, if one of these evaluated a false, so it's going to come in here and say, oh, so we're going to return true. Now, we're going to come into here. If the left side, if the floor is greater than or equal to the other one's floor, and this one's floor is less than or equal to, right, if the left side, oh yeah, excuse me, that's what it was, okay. So if the left side is less than or equal to the other one's left side, is greater than or equal to it, and it's less than the right wall, then that means it fits within the x-axis inside the room. Well, we need to check to see if it fits in the y. So we'd say the roof of this one, check to see if it fits, if it's greater than or equal to the other one's room, and if this position is less than or equal to the top wall. This is the ceiling. So basically you want to say if it fits within the room, and it's the same thing for these two. You got the roof. Is it greater than or equal to the other one's floor? It is. It'll fit in the y position. Okay, well then, is this one's roof also less than or equal to the other one's roof? It is. Okay, so that means in the y position, it fits inside the room. But does the x position fit too? So if the floor, if this dot x position, the left side, is greater than or equal to that one's left side, and this one's left side is less than or equal to the right wall, that means the left side also fits inside the room. So the roof, so that means the top left corner does fit in the room. And then the very last one here is, if the right wall is greater than or equal to the other one's left, and the right wall is less than or equal to the other one's right, that means x-wise, that means on the x-axis, it fits in the room, but it might not be in the y-axis. So we have to check to see, with the AND operator, to see, okay, this dot y, the floor, is greater than or equal to the other one's floor, and its floor is also less than or equal to the top wall. So because of these two things being true, it is overlapping, so we return true. So that'll fix the corners. Well, there's another thing we need to check too. We need to check to see if it's going to overlap in the width. So we'll do else if So we need to check to see right here. Overlap by width. So now we need to check to see if it overlaps in the width. Else if this dot x position is less than or equal to the others dot x position, and this dot right wall greater than or equal to the others dot right wall, and this dot y position greater than or equal to others dot y position, and this dot y position less than or equal to the other wall, or this dot top wall less than or equal to the other dot top wall, and this dot top wall is less than or equal to the other one's top wall, and this dot top wall greater than or equal to the other dot y position. This is all for width. Go down, make it OR operator. Close this off. Or come down here. And now this is where we're going to do overlaps by height. So let's walk through this one real quick. So if the x position of this room, if the left side is less than or equal to and the other one's left, and this one's right wall is greater than or equal to the other one's right wall. So if this left side is less than or equal to okay, nope, never mind. This dot x position less than or equal to the other ones, and this right wall is greater than or equal to the other's wall, and the y position is greater than or equal to the other's y position, and this dot y position is equal or less than the top wall, so the y position fits, or the y position is less than or equal to the other one's top wall, and the top wall is greater than or equal to the other one's position. That would be the width. Now, to do the height, what we're going to do is this dot y position less than or equal to other dot y position, and this dot top wall greater than or equal to other dot top wall, and this dot y position less than or equal to other position, this dot top wall greater than or equal to other top wall, and this dot x position greater than or equal to the other dot x position, and this dot x position world that was x position. Alright, so this dot x position is greater than are equal to the other's x position. This dot x position is less than or equal to the other dot right wall. Or this dot right wall is less than or equal to the other right wall. This dot right wall greater than or equal to the other dot x position. Close it. Now here, we're going to return true. The intersect. So let's wrap this one real quick. So if the x position is less than or equal to the other one's x position, okay, and the right wall is greater than or equal to the other one's wall, and the y position is greater than or equal to the other one's y position, and this dot y position is less than or equal to the other one's top wall, or this dot top wall is less than or equal to the other one's top wall, and this dot top wall is greater than the other one's y, that'll return true if it's by width. So by height, we're going to say, hey, if this y position is less than or equal to the other's y position, so that means it's going to be within the height of the room, and its top wall is greater than or equal to the other one's top wall, and this x position is greater than or equal to the other's x position, and this dot x position is less than or equal to the other's right wall, or this right wall is greater than or equal to the other one's, less than or equal to the other one's right wall, and this right wall is greater than or equal to the other's x position. So this is how it's gonna, I think I actually have these backwards, because this looks like it overlaps in height. Y position is greater than or equal to the other one's y position, and its y position is less than the other one's wall, or the top wall is greater than or equal to the other one's top wall, and this dot top wall greater than or equal to the other one's y position, and less than the left of this top's wall is less than or equal to the other one's top wall, and its top wall is greater than or equal to the other one's y position. Yeah, I have these backwards. Okay, so this one's the height actually, and then this one's the width. My bad. There you go. One more we have to do. Else if this dot size is greater than the other room's size. That's it. That's all we gotta do there. And then we'll do possibility check if room can fit inside the other room. So if the size, all you gotta do, you can check any corner for it, because if any corner, if this entire room is inside of another room, there's at least going to be one of the corners inside of the other room, obviously. We can just literally check the right top corner. Check the right top corner. any corner check would work. So we'll come into here and we're just gonna do if other dot right wall is greater than or equal to what is happening. Yeah. And the right wall is less than, so if the right wall is greater than or equal to the well, let's not get confused. This dot x position and other dot right wall is less than or equal to this dot right wall and other dot top wall is greater than or equal to this dot y position and other dot top wall is less than or equal to this one's top wall. Return true. And that is it. This is the entire function to check to see if the room were intersect. If we're laying down a room, we need to see if the right top corner intersects. If it does, you return true. If the left one, return true. Bottom left, top left, bottom right. If they overlap in height, you want to return true. If it overlaps in width, if this room can fit in the other one, return true. That's not what we want. Other than that, return false. Lay down the room. So where do we go to call this? We go into grid behavior. Inside of the create room function, we're going to be generating rooms, right? But we don't want to add it to the list until we know this room is going to be made. So that means right after we establish this room, we need to say for int I is equal to 0, I is equal to this dot room list dot count. So for each room in the list, so a room only gets added to the list after a room can be laid down. So at the very beginning, you're not going to have any room, so it'll just skip this and it'll come here and add the room and do it. Well, in the next iteration, it's going to say, okay, what's the room count? Now it's 1. Okay, let's loop. Well, let's check this room. So if the room that we just created intersects with this dot room list index I, the current index in the list, if it intersects with that room, what we're going to do is we're just going to return from this function. So what's going to come into here, it's going to create a room, randomize all the values, and say, okay, so this is the first time we're setting it up. We haven't put any rooms yet. I is less than the room count. The room count's 0. It's going to skip it. It's going to come down here, add the room, create the room, show it. Cool. Next iteration here. Go into create room, randomize it, create the room object, come into here. For it, the room list is now going to have 1 room. So we're going to come into here and say if the current room we created intersects with this room in the list, we're going to return from this entire function. So this code here never gets run. So therefore, this room never gets added to the list. So this room doesn't exist. We only want to lay down the room if it doesn't intersect with anything. And so we can go ahead and go in there and test it. We got the create room called. That's it. So now all we got to do is come back to Unity. Let everything compile up. Come back over here. When we hit play, see, it can generate a room of max 10. Before, no matter what, when a room we weren't checking for intersection, this would always be 10. Always, and I can prove it. So we come into here, we're going to comment out this code real quick. Here. We're going to comment this out real quick. So no matter what, every time I run Unity, okay, every time I run Unity, it's going to fill this room up. It's going to lay 10 rooms down no matter what. Okay? And we'll test it. We did it once. Here's your 10 rooms. Okay? Here's your rooms. La da da. Oh, that doesn't look like 2, 4, 6, 7. That only looks like 7 rooms. That's because some of them are intersected. So, we'll get out of there. We'll test it one more time. Gonna fill up back with 10 more rooms. So we did this twice. And if you zoom out and you look in here, do we have 10 rooms? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there's another room somewhere attached inside of a room and we can't see it. Or we can, it's just branched off somewhere. So we did that twice, right? Remember, every time it was 10, well, guess what? I'm going to uncomment this code. Come back into here. Play it. And I'll run it twice. Okay, so this one did 10. But notice they're not going to overlap. So 1, 2, 3, 4, 5, 6, 7. Oh, it's not working. Well, that didn't make any sense. How? Okay, 1, 2, 3, 7. Yeah. It shouldn't have generated that code. 2, 3, 5, 6, 7, 8. Okay. Oh, messed up in the code somewhere. So, okay. Well, I'll end the video here. I'm gonna go and figure out what the issue was. In the next video, we'll go and make the pass between the rooms. Between that video and this one, I'm gonna figure out what went wrong, and I'll explain it in the next video. But that is for the majority of it. We'll go ahead and get it started. So thank you all for keeping up with me this far, and I will see y'all in the next video.